Okay, welcome back, grade 11, to our last lesson for week 5. And what we're looking at here is we're looking at angles of elevation and depression. So what I've got here is I've got an example. So the angle of depression from a scuba diver at the water's surface to a hammerhead shark on the sea floor of the Great Barrier Reef is 40 degrees. The depth of the water is 35 meters. Calculate the horizontal distance from a scuba diver to the shark, correct to 2 decimal places. Now, again, this is always where students can get confused when we talk about angles of elevation and depression. So I've got a little triangle that I've drawn here. And what I'm going to do is just insert a couple of text boxes to show you how we express this. Okay, as I struggle to find where the text, there it is. Okay, so we're going to insert a couple, and I'll just copy and paste these. Just going to format them as well, so there's no outline. And now what we're going to do is first, let's talk about where the scuba diver is. Okay, so he's at the water's surface, and a depression angle, or an angle of depression, indicates that they're looking down from the horizontal. So the scuba diver is actually going to be up here. Okay, so there's our scuba diver. Now, next up, don't want that. Next up, just copy and paste this real quick. Really not liking me, is it? Doesn't want to copy it. There we go. Okay, let's talk about the shark. So we know that the shark is at the bottom of that angle, so the shark is going to be down here. Okay, now we're told that the scuba diver spots it at an angle of depression of 40 degrees. So the 40 degrees, where is that going to be? Let's pop a degrees. Actually, I'll just put degrees in just so I don't have to get the symbol. Now, because it's an angle of depression, the 40 degrees is actually going to be in there. I might make this text a tiny bit smaller, just so I can sneak it in a bit closer. Okay, so we've got a 40-degree angle of depression in there, and we know that the depth of the water is a total of 35 meters. So the depth is a horizontal one. There we go. Now, what we need to find is the horizontal. Now, when you think of horizontal, think of horizon, okay? And think of how the horizon stretches, just like along here. Okay, so what we're trying to find is our distance here. Now, I'll just put distance here, make this a bit bigger. And what we now need to do is think about how we're going to solve it. Now, obviously, it's already been given away. We're dealing with a triangle, a right angle triangle, I should say. Even though I haven't put it in there, we've got a right angle just over here to the 35, okay, to the sea floor. So to find this, we're going to use trigonometry because we have an unknown side, we have a known side, and we have a known angle. Now, what that means is we have to now label our triangle. That's the first thing we do when we're solving a trig problem. So distance, that horizontal distance, I should say, that is going to be our adjacent side because it is adjacent to our theta, our 40 degrees. Now, this 35 meters, on the other hand, that's either going to make it the hypotenuse or the opposite. It is not the hypotenuse of the triangle, so therefore this is the opposite side of the triangle. We don't need the hypotenuse at all to answer anything to do with this question. And of course, we have our degrees here, which is also our theta. Okay, I might just have to leave that, but that's okay. We've got our theta here now. So, as always, and I know this is probably the third video you've seen where I do this, we always start with our SO. So SO, ka, toa. Now, we're dealing with the opposite and adjacent, so toa is what we're going to be using for this example. Okay, so from here I expanded toa. T stands for tangent. Okay, so tangent theta, there it is equal to the opposite side over the, in this case, adjacent side. So there's my formula. There's step 2 done, okay? We label the triangle, we've got the ratio, now let's substitute. Tangent in this case is going to be 40 degrees. Our opposite we know is 35 meters. What we don't know is our horizontal distance. Okay, I'll just put DIST for the distance there. Okay, now rearranging this, okay, if you're unsure how to rearrange this, go back to 8.3 to see how I rearrange a very similar one to this. But effectively what it's going to do is the distance is going to be equal to 35 divided by tan of 40. Okay, and we can just pop that straight into the calculator and that will give us our horizontal distance. Okay, so I'm just going to do that now. Might just get some space back up here. Alright. We should be able to fit this on one page. Okay. Just doing the math now. So 35 divided by tan of 40. If you're not getting an answer of 41.71 meters, then there's probably been a calculator error. Make sure it is in degrees. So 41.71 meters, rounded to 2 decimal places. Then we just put our summary statement underneath that. Therefore, we're working out the horizontal distance between the diver and shark is 41.71 meters. And there we go. That's it for that question. Not an overly complex question, okay? A lot of the time, the hardest part with doing an angle of elevation and depression question is 1, drawing the diagram, and 2, putting the angle of elevation or depression in the correct place. A lot of students make that mistake, as you'll see with some harder questions. But anyway, guys, a nice short one for 8.5, and thanks for watching.